the phase level. It has two pieces. It's the sum of, did I erase it? Yes. Okay. Phi was minus tan inverse of omega tau minus okay. As omega goes to 0, log omega goes to minus infinity. What does this become? Zero, right? What about, so omega goes to infinity. As omega goes to infinity, I have two pieces. My tan inverse of omega tau goes to where? It becomes minus tan inverse of infinity. And would be the first infinity I find is minus infinity. So what's the first angle that would give me tangent infinity? Pi over 2, and with the minus becomes minus pi. Okay? Remember the trigonometric cycle? Okay? If you take any angle, and remember, if you take any angle, the sine is this distance over that. The cosine is this distance over that. Tangent is sine over cosine. So tangent becomes infinity when cosine becomes 0. As you increase the angle from 0, here is angle 0. As I increase the angle from 0, when does cosine become smaller and smaller? And when you get 90 degrees, cosine is 0 and you have infinity tangent. So this goes to this part infinity with a minus in front, minus infinity. Sorry, this goes to 90 degrees with a minus in front, minus 90 degrees. Remember, in the body plot, we use degrees, not radians. Okay? We saw that the tangent where that becomes infinity is 90 degrees. So tan inverse is 90 degrees. Clear? Sure? Yeah, I will discuss that in a minute. This I have to discuss each piece separately. Okay? And what about minus omega d? Oh, one other thing here. What would it be at the corner frequency? At omega equals 1 over tau. Where does minus tan inverse of omega tau go? Negative 45, exactly. I just want to put that. Mika.
What happens to the second term?
I will address it now. Okay, all this is just the first part. Okay, everybody clear about this part? So this part goes to minus 90 degrees, goes from 0 to minus 90, and becomes minus 45 at the corner frequency. What about the other part? Minus omega d obviously goes to minus infinity. And how does it go to minus infinity? Remember, I'm plotting here log omega. So this is minus d times 10 to the log base 10 omega. So it goes to minus infinity. How? What kind of curve is it going to be? Linear?
No, because you have a log.
No, I don't have a log. That's my variable. That's my x variable.
Oh, so linear?
Is that linear?
Exponential.
Say it, Felix.
Exponential.
Exactly. Exponential. So this is the sum of two curves, both starting at 0. One goes from 0, so here is my axis. Let's say here is 0. Let's put the 0 over there. So one goes from 0, minus 45 at the corner frequency, and ends at minus 9. That's the first part. And the second part, depending on how big the delays happen sooner or later, goes exponentially towards minus infinity. Yes?
Does it intersect the corner?
I mean, there are two different scales, two different axes, so it depends on your scale. And where you put the numbers here if it intersects. Okay? So, but this should be the same. We'll start as okay? Minus omega d is 0, goes to minus infinity exponentially as omega goes to infinity, and goes to 0 as omega goes to 0. So this is what, I tell you, let me draw them in white and I'll draw in orange or something. So this is the minus tan inverse of omega tau, and this is the minus omega d. So the sum of the two would be what? 0 plus 0 gives me 0, right? The way I have drawn it, this stays 0 here, so it would almost come here, but then the sum of the two becomes more and more negative going towards minus infinity. So the sum of the two would be 0. This is pretty much with what I'm just staying here. It would start. Okay, that would be this one. All right.
So
Great.
how do you get that last?
Okay. 0 plus 0 is 0, right? In this part, this is still 0, so the sum of the two is going to be the minus tan inverse. As this becomes more and more negative, this takes this and makes it further down. Okay? I'll tell you what. Let's look at some of them. Okay? Let's do some examples. I'll return to this. So,
A little break.
let's turn on. I'll tell you what, okay. I'd rather bring the commission immediately after the break. Are you okay if we take the break 10 minutes early? But it won't be a longer break.
10 minutes longer?
No, it won't be longer. So we'll start also class 10 minutes early. So, set up your computers. Let's take a 14-minute break. And we'll continue after the 14-minute break immediately with computers. I'll bring the software and I will draw some body plots to see exactly what I'm
Let's see your homework really quick.